A major new paper has just dropped from the Chinese AI startup Deepseek, and you're going to want to hear this. It's sending some serious shockwaves through the entire industry because they've unveiled a new way to train AI that could solve one of the biggest problems holding back progress. Okay, let's get into it. And let me tell you, experts are not holding back. Analysts are calling this a striking breakthrough, something that could fundamentally change how the huge AI models that power our world are built. And look, this isn't just some minor tweak. We're talking about a whole new playbook for making AI smarter. And it's coming from a company, Deepseek, that's proving to be incredibly agile in this AI race. Okay, real quick, if you want to stay on top of breakthroughs just like this one, it would be awesome if you took a second to subscribe and like our channel. It really helps us out.
So, to really get why this paper is such a big deal, first we have to talk about a massive challenge that every single AI lab is facing. I don't care if you're a giant like Google or a startup like OpenAI, it's called the scaling problem. And to put it simply, making AI models bigger and smarter is just incredibly, brutally difficult. Think of it like a game of Jenga. Seriously, to make an AI model more powerful, you want all the different parts of its brain to talk to each other more. So you're adding more and more blocks and connections to the tower. But the more you add, the more complex and wobbly the whole structure gets, until it's on the verge of collapsing, or in the AI world, becoming unstable and just failing. And this right here is the fundamental trade-off. It's the core dilemma. On one side, you want to increase the model's size and get all that rich internal communication to make it smarter. But on the other side, that exact process makes it way more likely to fail, and your computing costs just go through the roof. It's a bottleneck that has been frustrating AI development for years. Okay, so that's the problem. And this is where Deepseek's new paper just changes the game. They've come up with a really clever solution to get around this trade-off, a brand new method for growing AI models without them falling over. They call it Manifold Constrained Hyperconnections, or MHC. The name is a mouthful, I know, but the idea behind it is actually brilliant. It's basically a way to let the model have all that rich, smart internal communication, but you do it in a very controlled way. It's like finally figuring out exactly where to put the support beams in our Jenga tower so we can keep building higher without it collapsing. So let's break this down step by step. First, you open the floodgates and allow for all those rich connections that make the model smarter. But, and this is the genius part, step 2, you add these smart architectural constraints that act like guardrails, keeping the information from just turning into chaos. And the result? Step 3, you get a huge leap in performance without the instability and without the crazy extra costs. It's pretty incredible.
So, okay, it's a clever technical solution. Big deal, right? Well, yeah. It's a huge deal. And here's why this paper is making waves way outside of just the engineering world, because the implications here are about so much more than just one company or one model. You see, by publishing this research for everyone to see, Deepseek isn't just sharing a cool discovery, they're making a huge strategic move. As one chief analyst at Omdia put it, this signals a newfound confidence in China's AI industry. It's a total power play. They're so confident in what they've built that they're basically showing their cards to the world, trying to shape the global research conversation and challenge the dominance of Western labs. And this move makes so much more sense when you look at their roller coaster of a journey lately. Just a year ago, they had their own Sputnik moment when their R1 model blew everyone away by matching top competitors at a fraction of the cost. But then their next model, R2, got delayed because of performance issues, which means they probably slammed right into that Jenga problem we were talking about. This paper is them saying we found a way to smash right through that wall. So let's just quickly recap why this is such a game changer. First off, it's super efficient, which is key for keeping training costs from spiraling out of control. Second, it shows Deepseek can pull off some really rapid, unconventional research. And maybe the biggest deal of all, an approach like this could help get around major hardware problems like chip shortages. And you can bet that right now, every rival lab is scrambling to figure this out and build their own version. All right, so Deepseek has this incredible new tech, and it's out there for the world to see. What happens now? What does this mean for their next model and for this whole race for AI supremacy? So when are we actually going to see this tech in a real product? Well, the experts are kind of split on this one. Omdia's Lianjie Su thinks based on their history, Deepseek will pop this right into their very next model, the one that was delayed, R2. But Wei Sun from Counterpoint thinks they might be playing a longer game, that this will be the powerful backbone of a future even more advanced V4 model. But here's the reality check. Even with this amazing breakthrough tech, Deepseek has this one giant hurdle to overcome: distribution.
Having the best tech doesn't mean you automatically win. Deepseek still doesn't have the massive global reach that behemoths like OpenAI and Google have spent years building, especially in those really key Western markets.
And that leaves us with the big question, doesn't it? In this incredibly high-stakes race for the future of AI, is a revolutionary technology enough to win? Or in the end, does having that global reach and market power just matter more? DeepSeek has just made its move. Now we all get to watch and see how the rest of the world responds.